Quite the bibliography. All right, so now I'd like to welcome up our sustainability science capstone group. The presenter will be Bridge, and their client was the New York City Department of Health and Mental Hygiene, and their faculty advisor was Beizhan Yan.
All right. Hello, everyone. My name is Bridge Banerjee, and I am presenting on behalf of the Sustainability Science cohort. Our capstone project is on the New York City Clean Heat Program, in which we do a retrospective analysis of boiler fuel transition. So before getting into it, we want to cover a little bit of background. Then we're going to break our project down into 4 tasks, and then hopefully leave you guys with some recommendations. So our client was the New York City Department of Health and Mental Hygiene. Now, NYC DOH-MH is one of the largest public health organizations in the world. They serve and protect the health of over 8 million New Yorkers. Of the many undertakings with which they're involved, they study the patterns, causes, and effects of health and disease conditions in New York City neighborhoods. This is used to inform the city's health agenda and shape policy decisions. Of their many goals, 2 of their top priorities are to create healthier neighborhoods and implement anti-racist public health practice. To this end, we aim to incorporate these perspectives in our analysis. So in the intersection of public health, equity, and environment, our project looked at the New York State Clean Heat Program within NYC. Now, this is separate from the program incentivizing electric heat pumps. This particular program worked towards transitioning boiler fuels from dirtier ones like number 6 and number 4 oils towards cleaner ones and natural gas. Now, in 2009, residential buildings burning number 6 and number 4 oil accounted for 1% of buildings in New York City. However, they also accounted for 86% of PM 2.5 emissions. So one of the expected outcomes of this program is to reduce PM 2.5. PM 2.5 is a very small particle, a fraction of the diameter of a human hair, that can get into your lungs and cause oxidative stress, which will worsen conditions with asthma and heart disease. Now, these effects are particularly pronounced in New York City, where we see 3,000 premature deaths, 2,000 hospitalizations, and 6,000 asthma-based emergency room visits annually. The magnitude of these impacts from boiler fuel PM 2.5 contextualizes the necessity for our analysis of this program. So to do this, we broke our project down into 4 tasks divided by major themes in sustainability: environment, health, economic, and equity. Findings from each of these will influence recommendation that will be used to guide future energy transition policy. So our first task was to suss out how much PM 2.5 was actually coming from boiler fuels. So we did this by using EPA's positive matrix factorization model, which takes large numbers of variables and data sets and kind of distills them down into combinations of species called source profiles and source contributions. Now, the one in particular that we're interested in is the boiler fuel one. And this fingerprint was enriched in nickel and vanadium, as you can see by this top graph here. Now, additionally, we can also see a seasonal fluctuation associated with heating fuel practices. That's shown by the second graph here. There is a higher usage in the winter months and less in the summer. So from 2011 to 2016, the bookends of this program, we found a nearly 80% decrease in boiler fuel PM 2.5 in New York City. This is consistent with the program's goals. Now, using this data from task 1, we're able to get into our health analysis. We used a tool called BenMap, which is an EPA tool for estimating health impacts and medical cost savings associated with changes in ambient air pollution. It accomplishes this by running health impact functions that associate changes in the concentration of a pollutant with changes in the health endpoints. We found that 934 lives were saved in 2016 due to PM 2.5 reductions from 2011 levels. This is associated with medical cost savings of $7.4 billion. Expanding on the economics, we wanted to retroactively estimate operational and capital costs associated with fuel transitions. We use energy use data by fuel type from Open Data NYC to determine fuel switches between 2011 and 2016. Now, of the approximately 1,400 buildings that self-reported using number 6 fuel, we found that the majority switched to natural gas, as can be seen in the table over here. Now, since this data is self-reported, there is a substantial degree of uncertainty with these proportions of switches. We suspect that our segment of data is a small fraction of the buildings that actually burn number 6 oil. This is consistent with a 2014 NIH study that found that about 53% of the buildings yet to convert from number 6 fuels were in Upper Manhattan and the Bronx, as you can see here. For the buildings that did switch, we calculated operational cost savings. We took the fuel type and consumption data from Open Data NYC and estimated what % of fuel would be used for space heating as opposed to cooking or heating water. Now, per square foot, converting to natural gas resulted in the most operational savings. For capital expenses, however, we had to perform a desk analysis because we did not have access to structured data sets. We got our data from interviews and other research on the matter. Now, the cost of switching to lighter oils, like number 2 oil, was around $5,000 to $17,000, depending on the combination of burner tank and oil lines and their condition. Switching to natural gas, however, can be very expensive, costing hundreds of thousands of dollars, depending on building infrastructure and the piping. So next, we wanted to get into metrics that kind of involve equity. Our analysis investigated associations between CDC Social Vulnerability Index data for New York City and PM 2.5 from boiler fuels using Geoda and open source GIS software. First, we looked at fuel switching and vulnerability. We designated arbitrary fuel switch scores depending on what the boilers switched to. The cleaner the fuel, the higher the score. Got a little key right there. And we correlated this against poverty and minority status, which are 2 vulnerability indicators designated by the CDC. We did not find a strong association between the vulnerability indicators and the fuel switching choices. This is consistent with current literature about the program that stated that the goal of it was to target sector-specific emissions rather than sensitive populations. We then looked at associations of PM 2.5 data and poverty to see how the program addressed socioeconomic vulnerability. Though the Clean Heat program benefited everyone in the city due to citywide decreases in PM 2.5, it was difficult to find consistent results among research about equity. Our analysis suggests that New York City's story is one of 2 worlds. In Manhattan, we saw a negative association between PM 2.5 and poverty. Now, this is likely due to the high concentrations of PM 2.5 that is present in lower Manhattan wealthier communities. In the other 4 boroughs, we see an opposite trend, more consistent with what we would expect. We see higher PM 2.5 associated with higher incidence of poverty. For all boroughs, associations with change in PM 2.5, or the deltas over time, they paralleled their trends from 2011. Now, since this investigation, though, is retrospective, we wanted to look at the endpoint, or 2016, at the time of full number 6 phase out. From this, we found that the trends very much paralleled their 2011 counterparts, suggesting little change over time. This is consistent with current literature regarding inequity in that we see changes in PM 2.5 over time, but we see relative increases in disparity among different communities. So I know I threw a lot at you right there, so we kind of distilled our findings into a nice color-coded table for y'all. So environment and health was the most clearly successful from this program, where we saw 80% reduction in boiler fuel PM 2.5 emissions. This saved nearly 1,000 lives in 2016. Economics was a little more difficult as we see savings in operating and medical costs, but capital costs of switching is prohibitive. And equity is also very difficult because there are complex dynamics in New York City, but we did not see improvements in PM 2.5 and SVI association from 2011 to 2016, suggesting that there is more work in this area. So we use these to kind of inform a couple of recommendations, two of which are right here. Now, one of them was recommending borough-specific intervention for fuel transition because our data reflected that there are different trends across boroughs with the relationships between air pollution and their communities. Additionally, we recommend that improved data collection and documentation practices are focused upon because at every point along this investigation, we encountered hurdles with data quality that kind of hindered our investigation. So improving this is a really feasible way to improve further analyses in the future. So with that, thank you so much for your time. I'm happy to have take any questions you guys have.
Thanks for the presentation. I thought that was really interesting how you broke out Manhattan separately. I was wondering if you could just speak to some of the causes of worse pollution in lower Manhattan.
So that was primarily driven by where our gridded data sets of PM 2.5 were from. We could see trends of higher PM 2.5 associated in those regions. And I think a lot of it was due to there are a lot of older buildings there that have old boilers that burn number 6 fuel. So that was our primary way of looking at that. And then also we looked at income distributions and they kind of overlap.
Hi, once again, thank you. Did a wonderful job. Going similar off her point, you noted how Manhattan kind of stood out as an outlier. Was there any other borough that showed a more significant correlation or anything that was like kind of reflecting, again, more of what you were expecting to a more significant degree than the other boroughs?
So the boroughs all varied in their own ways. We grouped them this way because they were in the same direction as opposed to Manhattan. But one borough of particular note was the Bronx. And so one thing about this is a lot of the health impacts paralleled a lot of the pollution concentrations, and there were high concentrations of PM 2.5 in the Bronx. So that was like an area going into this, we had kind of from the literature, we're interested in looking at that. But just for like a high level summary of everything, we just broke it down, Manhattan and the other boroughs. All right, thank you guys.